Assalamu alaikum. My name's Rashid. I'm an engineering student from Nairobi campus, Kenya. Today, I wanted to show you why do we say that the derivative of cos x equals to minus sin x, and the derivative of sin x is just cos x. Today I'll prove that, and follow up with my videos for more updates. Just subscribe and activate the notification tab. So applying first principle. So first principle says that currently I've shown in my videos, I showed that why do we say that for any dy dx, for any derivative of a function, we can say that limits of h approaching limits of h approaching 0 of function of x plus h minus function of x all over h. For we to get the derivative of any function of x, we can use this formula. So follow up with my videos. I have a video of how we obtain this. I currently uploaded it. So for we to get any derivative of a function, we can use it. We can use this function to come up with any derivative. So let's start with, given that the function of x is just cos x. That is the function of x. Now, remember h is approaching 0. So follow up with my video. I'll show you on limits. I'll talk about limits in my next video, and follow up so that you can understand more about limits. So the limit of h is approaching 0, meaning that we added, since you have given a function of x as shown below, therefore the function of x plus h, where h just is very small, that approaches 0, is just cos of x, we add h. I think we understand that. So getting these two functions is very simple. Given a function of x, therefore the function of x plus h is just you add x with h. Therefore, applying that formula, getting dy over dx is just limits of h approaching 0 of function of x plus h, which is cos of x plus h, minus the function of x, which is cos x, all over h. Therefore, let's deal with this first. Let's just deal with this. After that, we'll come and substitute these other values later. Let's simplify this function. So, since we have function of cos of x plus h, this we can apply compound angles to expand this function, which is say that given a function of cos a plus b, therefore expanding this function, just to take the cos of a multiplied by cos of b, then minus sine of b, sine of a multiplied by sine of b, multiplied by sine of b. So let's expand this function using, so suppose x and h are a and b respectively, therefore cos of x plus h just, so cos of x plus h just cos a cos b minus sine a, which is x, plus sine b, which is multiplied by sine b, which is sine h. Therefore, we have our expansion. Just take this expansion and come and substitute there. Instead, we're writing cos of x plus h. Let's write our expansion. So cos x cos b not cos x, cos b, but cos x, cos h. I'm sorry for that, my subscribers and my viewers. So cos x, cos h, then minus sin x, sin h, minus cos x all over h. So mathematically it's correct for we to do this. Divide by h, by h, by h. Therefore, cos of x, cos h over h, minus sin of x, sin h all over h, minus cos of x all over h. So far we have that function. So, but the limits of h, let's come back to our equation. It says that limits of h is approaching 0. So the limits of h is approaching 0. Now, what to ask yourself in this step is that what happens when cos of h over h, cos of h over h, and h approaches 0? What happens to this function? Mathematically, when cos of h over h and h approaches to 0, this function automatically becomes 0. Therefore, we just say, so the limit of h approaching 0 for that function is just cos x multiplied by 0 minus the limits of sin of h over h. When h approaches 0, this function mathematically becomes 1. Therefore, and finally, cos of x over h. When h approaches to 0, this function just becomes 0. I think you're understanding. And when you are not understanding, just follow up with my video. I'll show why do we say that cos of h over h and sin of h over h equals to these values. This is what we know as limits. So in my next video, I'll talk about limits. So don't be confused on that. Therefore, the derivative dy dx, it will be just minus sin of x. Hence shown that the derivative of cos x minus sin x is just the derivative of cos x just minus sin x. Now let's talk about why do we say the derivative of sin x equals to cos x. Let's prove that. So given a function now equals to sin x, therefore the function we can for you to differentiate this function, we just take the limits of h approaching 0 of function of x plus h minus function of x all over the all over h. So let's determine the function of x plus h, since we already have the function of x. So the function of x plus h is just sine of x plus h. I think we are all together. So this differentiation formula, it says that for any derivative, for you to get any derivative, you just take the function of x, but x, you increase x slightly by h, which that h approaches 0. It's almost 0. Just add with a small value. It adds very small value to this function, but just add wherever you see x, just add with h before doing anything. Then you subtract from the function of x, then all over that h, you just get that derivative. Therefore, since we have the function of x plus h and function of x, therefore let's take them to our expression, which say that for our any derivative dy dx of any function, just this function, which is sine of x plus h, then minus sine x all over h. So expanding this one using compound angles is just sine of x cos of h, then plus sine of h cos of a, which is that one. So for you to expand this one, just apply the compound angles. So minus sine x. Then we can divide this function by h. So since this one is the derivative for this function, we can write it in this form. Therefore, dividing by h, this function just sine of x cos h over h minus sine h over h cos x minus sine x over h. So since the limits of cos of h over h when h approaches 0, but in this function, our h is approaching 0. So the limits of h approaching 0 for cos of h over h is just 0. So 0 times sine x is just 0. So it will be, so dy dx is just 0 minus. So I'm sorry that we had to, it was addition sign here. So I'm sorry, my viewers, just a mistake. So then the limits of sine of h over h when h approaches 0 is 1. Then 1 multiplied by cos x is just cos x. Then sine of x over h, you know h keeps on going to 0. When x is going to 0 from a larger value, this value is just becomes 0 because this is like it's constant. Therefore, the limits of this any function of x when the denominator is approaching 0 point something, then this function, you can see the change that the function is continuing becoming smaller and smaller. That's why we say is 0. The limits of that function is 0. In my next video, I show you why do we say that cos of h over h and sine of h over h this is 1 and this one is 0. The limits of these two functions are 0. I'll show it in my next video. So just subscribe and follow up with my video. Comment so that I can know that you are benefiting from this video and you are interested in these videos for me to upload more and more videos on this. So therefore, the derivative of dy dx is just cos of x. Hence proved that the derivative of sine x, which is here, is just cos x. So subscribe to my video so that you can get more and more math concepts concerning calculus and other various concepts in mathematics. So I wonder why most of students say that mathematics is hard. I assure you that mathematics is one of the most easiest subject in the world. That is what I can assure you. So just follow up with my videos and I'll show and I'll talk about how mathematics is the easiest subject and why. So just subscribe and just press just activate the notification tab, so that whenever my video are uploaded in YouTube channel, you just get the notification. So thank you very much and welcome to my channel.